Hello everyone. So today we will be talking about something very important when it comes to dealing with measurements. Now, in the past video, and I'll leave a link to that video right here, in case you haven't seen it. In that video we were talking about how to take a measurement from a graduated cylinder or something that has a graduated part in which you can compare the liquid that you have in to get an accurate measurement of its volume. It can be a burette, it can be a graduated cylinder, but how to take a measurement from that. And we're talking about what marks the meniscus. The meniscus is a curvature that appears at the top of the liquid and where to take the measurement from. And we touched on a very important topic that time, which is when I take this measurement, I have some digits that I know for sure, and I have a digit that I do not know for sure that it is the actual number that we have there. Because from between these two lines, I know the number is between 45 and 44, pretty close to 45, but that's as much as this grid is telling me, right? I cannot know much more precisely where my measurement falls. So this digit right here is where we take a guess on where that line falls, on where that meniscus falls. And that introduces us to what our sigfigs are, significant figures. Significant figures. So in this video we will be talking about significant figures, and the first point we will be touching on is what significant figures are. Then we will be talking about how significant figures work. And the last thing we will be talking about is some examples on how to count the amount of significant figures there is in a measurement. Alright, so let's get into it. So let's start with what significant figures are and what they tell you from a number. Basically, what significant figures tell you from a measurement is the amount of uncertainty there is in that number. What these significant figures do is they tell you up to which digit are we sure the number is for certain. So, what does that mean? How does that look like in a practical setting? So let's go back to the example we had in the previous video. Right, we were measuring the amount of liquid we had here, comparing it to our grid, right? And we found that the meniscus fell between 44 and 45, closer to 45, so we designated this number as our measurement in milliliters, right? 44.9. What significant figures tell me from this 44.9 is that all of the digits, that 4, this 4 right here, up until the last digit we have, are for certain that number. So we are sure that this measurement is at least 44. We know that those are fixed from our measurement. The last digit that we have written down, that 0.9, is the one that we don't know for sure. So significant figures tell me that whatever number I have written down, the last digit is the one that can vary. So this 44.9 might not be 44.9. It could be 44.8. It could be 45.0. It could be maybe 44.95. It could be anywhere near this 44.9. Maybe it could be 44.7 as well. But we know that these two are for certain. In this case, in this 45, it's really close to 44.9, right? So it's almost for certain that this was a 4, maybe a 5, right? But what significant figures tell us is that the last digit that we have is the one that is going to vary. Alright, so then how do these work in a practical setting? How do significant figures work when I'm taking a measurement, for example? Let's say we have a reading like this one, right? Where we have our meniscus right there. And let's take a closer look and try and take the measurement from this, right? So we know, first things first, right here is the bottom of the meniscus, so that's what we take as a reference. And if you don't remember some of this stuff, it's okay. I reviewed this part of taking the measurement in the previous video. I'll leave a link there. So we know that the bottom of the meniscus is right there, and it falls somewhere around here. So we need to figure out what those lines right there are, right? So we have 30 right there at the bottom. We have 30, and we have 40, right? So we have 10 lines in between. So that means from 30 to 40, there's a 10 units space, and it's divided in 10 spaces. So that means that I'm going 1 unit per space or line, right? Now what that means that, okay, if I'm on 30 right here, this is going to be 31, this is 32, this is 33. And our line falls between 32 and 33. Okay, so we know it's at least, we know this measurement, it's at least going to be 32, and it's a bit more, and it seems to be falling in between 32 and 33. So here's where our uncertainty comes, right? Here's where we need to make a judgment call. Hey, this seems to be maybe in the middle of 32 and 33, so I'm going to put it at 0.5, right? Here's where our significant figures come in play, because this right here has how many significant figures? Well, it has 1 for certain, 2 for certain, and the third one is the one that is not for certain. So that's where we stop counting our significant figures. So this has 3 significant figures. Right? This is the uncertainty, and it's in millimeters. Okay. And remember, this thing right here does not mean that this is precisely 32.5, but it means that it could be around 32.4, it could be 32.6, or it could be even 32.7, it could also be 32.3, but it has to be near 32.5, right? Here's where the uncertainty is. This is what significant figures tell me, that the uncertainty is in the last digit that we have there. Okay, so here we have some examples. Let's take a look at them. Now, we want to determine here how many significant figures each of these measurements has. Let's start with the first one. 14.2 kilometers per hour. Let's say you're driving and somebody measures that velocity, you're going pretty slow. Then how many significant figures do we have here? Let's count how many digits we have until the last digit that we have written down. So we have 1 digit here, 2 digits here, and this is the last digit that we have, right? So that means that these two are for certain, and this is where the error might be. That's where the uncertainty is, right? So we have then 3 significant figures. Let's look at the next example, 3.578 kilograms. So let's count again. We have the first digit here, 2, 3, 4. That means that this last one is where the uncertainty is. This could be 3.577 or 3.579, around there, right? So since we have 4, including that one, 4 digits, so that's 4 significant figures. Let's take a look at the next one then. 3.2 kilograms. Well, how many digits do we have? We have 1 and 2. Here's where the uncertainty is. So we have 2 sig figs. Here's the interesting part. You might see this one right here, and you might say, oh, we have 1, 2, 3 digits. This is where the mistake is, so, or where the uncertainty is. So this is 3 significant figures. That would be a wrong statement. Why is that? Why would that not be correct? Because we want to start counting from the digit, from the first digit that gives us information about this measurement. When you have zeros, before that first digit that gives you information, those zeros do not count. That is, you need to scan the number to find a number that is not zero. The first number that is not zero is the one you start counting on. Whatever zeros you have to the left of that do not count as significant figures because they don't give you any information about the measurement. So, in this case, then since we do not count this nor this, we will have just one number here that gives us information, and that is also coincidentally where the uncertainty is. So this right here would be a number with one significant figure. The next example is similar, right? We have 0.5 centimeters. So in this case, well, we need to scan the number and see its digits. Well, we start with the 0. The 0 does not give us information, so we skip it. And then we find the 5, which is something that is not 0. That means it's giving us information. So right here is where we start counting, and we don't have any other digits left after that. So that means that here's where the mistake is, or the uncertainty is. And that's just one digit, so this is one significant figure. So now let's take a look at some other examples. Here it's going to be clearer why we don't count the first zeros, right? So we start checking on this first number, for example. Okay, this is the first digit that we have. It's a 0, so it's not giving us information. So let's go to the second one. It's still a 0. We skip, we skip, we skip, and we skip all the digits until we get to this 2. Because that 2 is the first digit that is giving me information, right? So this counts as a significant figure. Then the next one is also giving me information. That counts as a significant figure as well. And this 7 is the last one that is giving us information, right? So in this case, we would, despite having like many digits, the only ones that are giving us information here is those 3. So we have 3 significant figures. And now let's take a look at these two. What is the difference between these two? You would say, okay, you have a 0.3 meters on this one, and the other one seems to be the same thing, just with a 0 there. These two mean two different things, because let's check at their significant figures. The zeros we do not count, because they are to the left of what the first point of information is, right? This right here is a digit that gives us information, and it's the last digit we have. So this has one significant figure. Let's try and do the same on the other one. This first 0 does not count. This is the first digit that gives us information, and zeros to the right of that digit also count as a significant figure. Why? Because if you have a 0 after the first digit that gives you information, that 0 is also telling you where your measurement is. The zeros before that first measurement or that first digit do not tell you anything, but the zeros after tell you, okay, that's 0.30 and not 0.31, or maybe it is close to 0.30. So this right here, this 0.30, does not only have one significant figure, but it has two significant figures. So the top number might mean, okay, this could be 0.2, or this could be 0.4, and so on. But the last one is telling me, okay, maybe this is 0.31, or maybe this is 0.32, or 0.29, right? So these, since this one has more significant figures, this one is more precise, in the sense that it's not going to vary as much as the other one. So the more sig figs you have, the more precise your measurement.